I'm Ian Clark, and this is my Interactive Advanced Concept Presentation 7, Balloon Geography. It covers electron domain geography with the addition of lone pair electrons. So we'll run through all the different variations of these and explain them a little bit, give an example of each, how many lone pairs there are. So normally you have a central atom, and then you have bonded atoms around it, and then we determine the geometry from there. But if you add lone pairs into the geometry of a molecule, it changes whenever there's one or more lone pairs added in there, depending on what type of molecule it is. So I have a large pile of balloons beside me. I'll do my best to demonstrate each the electron domain geographies with the balloons the best I can. I couldn't find a way to attach them really well, so I'm just going to hold them with my hand, and hopefully that suffices to explain this. So the first one has 3 electron domains, and the type of molecule would be like AB2. A is your central atom, B is your bonded atoms, and it'll have one lone pair of electrons. And the electron domain geography is called trigonal planar. And it will look something like this. So you have a central atom in the middle, you have your bonded atoms, and one of these would be your lone pair of electrons. And an example of this would be SO2, or sulfur dioxide. So you can kind of see the 3 there, 2 bonded atoms, central atom in the middle, lone pair. So next would be, and would have 4, there's 2 of these that have 4 total electron domains, the type of molecule. The first one would be an AB3 with your central atom, and then 3 bonded atoms and 1 lone pair of electrons. And it would look like this, where the bottom is kind of a triangle and one sticking off the top. If that, you can see that. And that would be considered tetrahedral, as you have the triangle at the bottom and the one sticking off the top. And the example of that would be ammonia, NH3. So the other one with 4 electron domains would be an AB2. So you'd have 2 lone pairs of electrons, and it would look the same, except your lone pair of electrons would be these 2 up here, with these being your bonded atoms. These 2 up here would be, depending on how you look at it, would be the 2 pair of lone electrons. And an example of that would be water, H2O. The next is 5 electron domains, and AB4. So it'll have a central atom, 4 bonded atoms, and 1 lone pair of electrons, and it'll be trigonal bipyramidal. So I had a hard time trying to figure out how to make this out of the bottom. So you'd have your 4 bonded ones, and then off to this side over here towards my face would be your lone pair of electrons. And it would be, an example of that would be sulfur tetrafluoride, SF4. So also in the 5 total electron domains would be AB3, so you'd have central atom, 3 bonded atoms, and 2 lone pair of electrons. And that would also be trigonal bipyramidal. And it would look the same, except you would have this one here, and the one out of the back would be your lone pair of electrons, opposing the 3 bonded. And then these 3 would be your, if I wanted to go straight down, my hand wasn't in the way, would be your 3 bonded atoms. An example of that would be chlorine trifluoride, ClF4. And then your third one with 5 total electron domains would be another AB2, which central atom, 2 bonded atoms, and 3 lone pairs. And it would also be trigonal bipyramidal, and it would look the same, except your bonded atoms would be opposing. They would be opposite, so it would be the one on the top and the one straight down, and these 3 around it would be your lone pairs. And an example of that would be IF2 negative, which is a gene. And for the last one, I'll grab one more balloon, would be 6 lone pairs, AB5. So you would have a central atom, 5 bonded atoms, and 1 lone pair. So an example of this would be if this one out of the bottom would be my lone pair, and it would be octahedral. So you have all your bonded ones on the top and your lone pair opposite everything coming out of the bottom here, if that makes sense. Or if you can see that well enough with these large balloons. And the last one with total number of electron domains of 6 would be AB4, so it'd be 4 bonded atoms and central atom, 4 bonded atoms, 2 lone pairs. So the lone pairs would be the top and the bottom, the one facing up and the one facing straight down. And these 4 around the center would all be opposing each other, and it'd also be octahedral. So your lone pairs would be going out the top and out the bottom, opposite of each other. An example of that would be xenon tetrafluoride, ZF4. So that's all the ones with electron domains from 3 to 6, with lone pairs ranging from 1 to 2 or 1 to 3, and the different electron domain geographies. Thank you.